Hey there, and welcome. Have you ever stared at a giant spreadsheet packed with numbers and just thought, okay, but what's the story here? Well, today we're going to learn how to use Python to make that data talk, to turn all those numbers into a real narrative. When you think about it, raw data is just a pile of facts names, scores, whatever. By itself, kind of useless, right? The real magic, the real value happens when we start asking the right questions. And that's exactly what we're here to do. We're going to use a super powerful Python tool to poke and prod at some data, piece by piece, until it starts to reveal its secrets. Okay, so to get started, we're going to need some data to play with. Our little sandbox for today is going to be a simple student report card. It's got names, it's got scores, it's perfect. And here it is. In the world of Python, this is what we call a NumPy array. Just think of it as a really, really efficient grid for crunching numbers. You can see we've got the student names over there in the first column, and then there's scores for 5 different subjects. So, you ready? Let's start asking some questions. All right, first things first, where do we even begin? A great strategy is to start with the big picture, and we do that by looking at one column at a time. So we'll analyze how every student did in a single subject. So, here's our first challenge. What was the average score for everyone in Subject 1? To do that, we somehow have to reach into our data table and grab just that one specific column. Here's the magic snippet of code that does it. Now, those square brackets are how we select stuff. But that little comma in the middle, that's everything. It's the divider between our instructions for the rows and our instructions for the columns. By putting a 1 after the comma, we're saying, I don't care about the other columns, just give me the 1 at index 1, which is our subject 1. So what's up with that colon before the comma? Well, think of it like a wild card in a card game. It just means give me everything. So when we put it in the row spot, we're telling Python, I want every single row. You put that together with our column selection, and boom, we've perfectly isolated all the scores for just subject 1. Awesome, we've tackled columns. But now, what if we flip it on its head? Instead of looking at one subject for all the students, let's look at all the subjects for just one student. So next up, how do we find the average score for just one student, say student 7, across all of their subjects? This time, we need to grab their entire row of data. Okay, so your first instinct might be this. Student 7 is the 7th student, so that's index 6, right? Because Python starts counting at 0. Then you just tack on .mean at the end to get the average. Seems logical enough, right? And error. But wait, don't panic. This is actually a really important moment. Understanding why this breaks is going to make you a much better coder. So what went wrong? Well, it's pretty simple when you think about it. The code tried to average everything in that row, and that includes the student's name. You can't do math on a name, so Python just throws its hands up and says, nope. So the fix is actually a neat little two-step. First, we select the right row, index 6. But then, and this is the key, we have to tell Python to ignore that first column with the name and only grab the columns that have the scores. And for that, we use something called slicing. And this is the code that does it perfectly. We grab row 6, but then look at the column part, 1 colon. That little slice says start at index 1 and just go all the way to the end. It neatly skips the name at index 0, and now we're only dealing with numbers. We can totally find the average of that. And boom, there's our answer. The real average for student 7 is 41.6. Okay, you've got the basics of slicing down, but now I'm going to let you in on a little secret, a gotcha that trips up pretty much everyone when they're starting out. Nailing this will save you so many headaches. Let's dial up the difficulty a bit. What if we only want student 7's average for subjects 2, 3, and 4? Not all of them, just that specific chunk in the middle. Now we need to define a start point and an end point for our slice. Okay, check out this code. Row 6, we know that part. Our slice starts at index 2. For subject 2, that makes sense. But wait a minute. To get subject 4, which is at index 4, why do we have to write a 5 here? What's going on? This, my friends, is the all-important n-1 rule. You have to burn this into your brain. In Python, a slice includes the start number, but it stops one step before the end number. So 2 to 5 doesn't mean 2 through 5. It means 2, 3, and 4. It's weird, I know, but once you get it, you've got it for life. All right, selecting rows, columns, slices, that's all great. But now, for the real power move. This is where we stop just grabbing data and start asking really smart, complex questions. So, here's the final boss question for today. Which students actually scored higher in Subject 1 than they did in Subject 2? See, now we're not just selecting data, we're comparing it. The way we pull this off is by building the condition first. It looks just like this. We're literally asking Python, for every single row, is the value in the Subject 1 column greater than the value in the Subject 2 column? And what Python gives you back is super cool. It's a list of true or false answers for every row. We call this a Boolean mask. You can think of it like a stencil or a filter. True means, yep, this row matches our rule, and false means, nope, move along. It's our own custom filter. Now for the magic. We take that mask, that list of trues and falses, and we just pop it right back into the selection brackets of our original data. It's like saying, hey, only show me the rows that I marked with a true. Then we add that comma 0 at the end to say, and from those rows, just give me the names from the first column. And what if we don't want the names, just the number, how many students matched? That's even easier. We just wrap the whole filter thing in the len function to get its length. Simple as that. And there you have it, 6. 6 students did better in Subject 1 than Subject 2. We've just answered a pretty complex question with just a couple of lines of code. How cool is that? Okay, let's bring it all home. We covered a lot, but it really boils down to 3 fundamental ideas that you can use right away. We learned 3 core techniques. First, selection, for pinpointing any single value you need. Second, slicing, for grabbing entire chunks of your data at once. And third, conditional filtering, which is the real game changer, letting you ask those deep, insightful questions. You master these 3, and you're well on your way. Look, we've just handed you the keys to the kingdom. You now know how to ask the questions, how to find the answers, how to make your data talk. So the only real question left is,